My name is Hugo Doucet. I am responsible for sales at Huawei Enterprise, and I would like to spare the next 30 minutes of your time about Huawei Dorado and how we are actually promoting this solution in the Belgium and Luxembourg market, and actually the success of this solution in that market. There will be three main windows or three main topics that we will discuss. First, I will try to give you a perspective on what Huawei as a company is doing with storage. We are quite a new player in this domain, at least for our region, and I think it's important that you understand from where we come and where we go. Secondly, I will have a deeper dive into V6 and what this is about, or Dorado V6. And then lastly, I will share some customer logos that we've recently won in the market. So what can we say about Huawei in storage? Because I think it's, at least in Belgium, not so easy to associate our company with the storage market. But if you look on a global basis, I think you can see that we've really grown into a very mature company. Today, we are the fourth largest player in the storage market in terms of revenue. In our mainland or homeland in China, we are by far the largest player. And if you look at all flash, and this is where we actually put most of our R&D in, is just all flash architectures and all flash concepts. We are by far the fastest growing company globally. And actually today, there was a press release by CNR that we were, even in 2020 Q1, the fastest growing company by far, outperforming all the other players, Pure, which is also specialized in all flash, and there actually was a decline for all the other players in their storage revenue. So we're doing quite well, and you can imagine, or you should wonder, why are we performing? What is going on? So if you look at storage or storage development at Huawei, you should see, or you should recognize that this is not an overnight. This is not an overnight initiative. Actually, development started nearly 2 decades ago in 2002. We have an R&D staff of more than 4,000 engineers, which is substantial. I worked almost 18 years in the storage industry. I've worked for NetApp, I've worked for Dell, I've worked for EMC, and I've partially worked for HP. And none of these companies actually had such a big R&D arm just on storage. And that reflects in our patents. Patents are very important for us as a company in terms of innovation. We have more than 8,000 patents. We are present in more than 30 industry organizations. So we're helping defining strategies, defining protocols for the future. We're very much into RoCE, which is RDMA over Ethernet, and a lot of the strategy is defined around that. In terms of R&D centers, what you can see is this is not just a China operation, it is a global operation. We have an office in Boston that is busy on defining the strategy. We have a presence in Russia where we're doing a lot of deep dive research on algorithms, compression algorithms. And that research is not just beneficial, of course, for the storage arena, because reducing data, compressing data is in the interest of the whole IT market. You know, transporting data a more efficient way by compressing it is a very cost-effective and smart way to do it. Maybe if you really want to understand how big this subsidiary is of Huawei, you could actually look at the bottom picture down here, and what you see is a picture of our campus in Chengdu in China. And actually what you see down here are these 4 large building blocks. Actually, these are 4 data centers filled with equipment from Huawei or from other vendors, and we do a lot of interoperability tests to make sure that our products are compatible with the industry as a whole. So if you look at the lifetime or how we've evolved over the last 20 years or so, what you see is that a lot of innovation was brought into our solution. I think some key elements is that in 2008, Huawei joined together with Symantec, and at that time it was Veritas, and found a joint venture. Out of that joint venture, I think the foundation was built for our solutions, our products. Later on, that joint venture was acquired by Huawei, I think for 300 million euro. And from there on, we started developing actually homegrown more and more our solutions. The latest innovation, I think the key products that were launched recently was in 2017 when Huawei launched their Dorado V3, and then actually 2 years later or 2.5 later, we launched an iteration of that product, which is now the Dorado V6. What I've seen when working with this company now nearly for 3.5 years is that what we're seeing is that the speed of development and innovation is by far much faster and higher than any other company you've ever worked for. And that really drives me to talk to customers and educate them about what we're doing and how creative and innovative these solutions are. If you look at our portfolio, we can clearly say that we have 4 main pillars on which our storage strategy is built. The first pillar is all-flash storage. The second pillar is a hybrid architecture, which we call hybrid flash. There is a third pillar, which is about distributed storage, and the fourth pillar, which has been in development for the last 2 to 3 years, which is what we call edge storage. The focus of today's conversation will be on the all-flash storage piece. But if you have some time, please feel free to have a look at our distributed storage portfolio. It's extremely innovative. We have some great white papers on that, and it's really amazing to see what is coming out of our R&D centers, and it's really amazing. Now, something also important to remember is that since all of these products are actually developed by the same engineering division, it means that a lot of compatibility exists between these solutions, meaning solutions like active-active, which we brand as Hypermetro. So Hypermetro is available as a solution on all these product lines. They're just maybe implemented a bit different, but in the way it's the same code, same software code, same philosophy, same idea that were actually implemented on all these product lines. Also, a lot of the overlay software that we're bringing to market, like a device manager, an orchestration tool, which we brand OceanStor DJ, or even cloud-based monitoring e-service, is compatible with all these storage lines. These products are not derived from an acquisition, and as such, we have a mismatch of portfolio. It's just coming from the belly, from the company itself, and it's being brought to market. And I think this is one of the key strengths of Huawei as a company. It's based on innovation, it's based on R&D, it's based on vision, and then from there products are built not for the short term, but for the long term. And at the speed at what we're actually evolving in these products is I think, not seen in the market. This strategy is successful for us. Over the last 9 years, we've really very rapidly moved into Gartner's Magic Quadrant for primary storage. We're winning a lot of prizes at Interop. And if you have the time, please go read on ESG Labs the reports they've done on our solutions and how they have actually valued what we've done in terms of innovation speed. So their ESG lab is really into validating the ideas and the concepts that were built in our labs. And then I think, okay, so before we dive into the V6, what you see here is a list of customers in various industries. This is a global customer base. What you see that we are present in every market. So in finance, in Switzerland, we're We are supplying services or providing. Swiss Life is one of our customers. We're very strong in the carrier market, also in Belgium. Media market, we have a very nice reference case with TF1. Large enterprises, Volkswagen, but also Renault, PSA are huge customers of us for storage. In the energy space, we do have a lot of oil and gas customers, and also in the education market, we have quite a lot of customers as well. Now, at the end of the presentation, I will bring back this slide, but actually bring it to customers, Belgian customers, so you can relate to maybe some people you know. Yeah. So going forward, I would like to talk to you about the single product that is probably the most differentiating in our portfolio, and that is the Dorado V6. So where do we position this product? We would position it in the down left corner. The product was launched, as you can see, about 6 to 7 years ago, and we're in its third generation of it. Obviously, Huawei is branding as the V6, but it's the third iteration of the platform. Okay, here's the timeline. So we started in 2009, but what you see is this is the original Ocean Store Dorado. Then we went to the V3, and now, just 2 years later, we actually launched the V6. And it's been quite a successful product, and I'm trying to explain you what makes this new solution so different from other vendors or other suppliers in the market. So what is the marketing messaging? The idea is that the Dorado V6 is a device that is extremely performant, so very low latency. We're not very high IOPS and very low latency. It's very reliable. There's a lot of reliability built into this to make sure that services are always available. And a new theme that was added about 2 years ago, I think Huawei started looking at AI and how AI could help automate processes and services. So this Dorado V6 has integrated some AI chips that will actually analyze the flow and make sure that the system is even more stable, better at providing services to end customers. And not just, by the way, this AI strategy is not just within Huawei, it's over the entire product portfolio. We're not just doing it for storage. If you would look at our data center switches, you would also see some AI capabilities built in to actually help customers get better at the services that they need to deliver. So ever fast, ever solid, and AI powered. So that's the three main themes of our solution. Now, I could have started this presentation around Dorado V6, around explaining you how the hardware looks and all of these innovations. But I think if you really want to know about what this solution is about, I highly recommend you to read a white paper. It's about 150 pages. A white paper about what this solution is about, how it's engineered, what are the innovative elements that were put into this solution. But I decided maybe to take it a different road. What I'm going to try to do in the next 15 slides is to explain you what two main ideas that we're using to differentiate the solution from other solutions in the market, and how it will actually help you to provide a better solution for your end customer. So where is it different? What are the key differences, and how can this help you to actually build differentiating products or differentiating solutions for your end customers? So this will be a talk about active architecture, and a second talk shortly will be about data reduction and how we're using this. Okay. So let's start in this. This might be a bit technical, and I apologize for that, but maybe in a second phase, what I'm going to do is try to bring these technical elements back to a commercial advantages. So if you look at a general or an average data center today in the Belux market, what you will see is that 90% of those data centers are virtualized or 100% virtualized by a virtualization layer. And I've actually listed here some common ones, so VM, vSphere, Hyper-V, Microsoft, and Huawei Fusion Compute. And in this diagram, you actually see 4 servers being displayed, 2 servers in one data center, 2 other servers in another data center, and the distance between these 2 data centers can vary. You know, some customers have them separated 20 meters. A lot of hospitals have them at 100 meters, 200 meters, and more of the high-end customers have very long distance between these 2 data centers, more than 100 kilometers. Yeah. And the general idea is that what you want to have is that all these servers are running at the same time and doing operations. And if one data center fails, you automatically want to fail over these services to the other data center. Now, if you look at how mid-range SAN architecture was built since 2000 up to today, it's always built around this idea of an architectural concept. It's called ALUA. And the base idea of ALUA is, I will explain you later. First, let me explain you what this is. So down here, what I've added in the presentation is a pictogram of a storage array. And most of the time, these storage arrays have 2 controllers. One to ensure availability, controller A and controller B. And what you see here are just logical ports allowing a server to be connected with that virtualization server to be connected with that array. Now, what we're doing, since what we want to do is have this volume that is stored here to be made available on all these servers because it's a virtualization layer, we're actually building a network in here. And this is where ALUA comes in. ALUA is an architecture that allows customers to build an active connection between a server and an array. But by nature, ALUA actually has this preference and non-preference path in the architecture. Meaning what you need to do and what most storage arrays actually will do is actually couple this volume to a controller and have like a standby or less optimal path going through another controller. This means that this array will communicate to this device that if you talk to me, I prefer you go over this path, and you can use this path, but it's less good for performance-wise. So a lot of traffic is actually generated, is actually going through this host. Now, since this volume is shared over all these servers, what you see is that all these devices actually will talk primarily to this controller and actually not touch this controller. And as a result, there is an unbalance in this architecture. As a customer, you're spending a lot of your money for a high HA environment, but you're not using it optimal, or the system is actually not allowing you, ALUA is not allowing you to use it in an optimal way. Now, if we would add it, so how is this solved? So what they normally do is to add another volume, and for this volume, the path is put in a different way. So they will put another volume here, and then this volume will actually be told that this controller is the preferred path. And this would allow you to balance the load over these 2 systems. Now, that's good, and that's a resolution to this problem. But on the other side, it's really creating some stress on the designer of the architecture, because he needs to make sure that everything is balanced at all times, and you don't even know when this is happening. It's not so easy to do. And so you need to have consultants come in, experts come in to help you, etc., etc. Now, it gets even more complex if you start adding. So this is this other path. It gets even more complex if you add a second array in the other part of the data center. What is happening here is that actually the communication between this device is primarily over this path, and this other device is just sitting there waiting to be come alive. I could call this, you could call this like a standby buddy. So in the end, as a customer, you're investing, if this would cost you 100 euro, you're investing another 100 euro, and this 100 euro is just there to protect your initial investment, but it's not doing anything. It's just there standing in a standby idea or architecture. And then some architectures would, if there's a failure here, would allow you to automatically start the services here. But a lot of architects even can't do that. So if there's a failure here, this needs to come live. It's not fully transparent. So it's a complex thing. So you need to have consultants come in to help you with that. Not easy to do. Then If we look at other suppliers and other vendors, for example, NetApp, what they've actually done is actually build a cluster or like a virtual array over these arrays. And that's already an advantage, meaning you can transparently move volumes from one array to the other array. And when you do that, this array will be aware, or this array will tell the host that the optimal path has changed. So it's now this way. But still, it's not active. It's not. So this is still a standby buddy, and this is an active array. If things move, then this guy becomes a standby buddy, and this array is then active. So a lot of load balancing is needed, and you also see it with other, not just NetApp. It's just other solutions. All rely on this base idea of a Lua, and with its limitations. So how are we different? So in Dorado, we're really pushing for this idea of an active architecture. This means that when you have a volume here that is represented on all these arrays, we're actually going to allow that each controller has its equal path and equal access to this volume at all times. And how do we do that? Actually, in the host, what we're going to do is we're going to have this host, this volume being split up in many thousands of tiny volumes, which are actually tiny mini partitions, which are actually living here. And then if this volume starts writing on green, and then the next millisecond starts writing on blue, and then the next millisecond starts writing on red, actually green will always have a preferred path, and it's by the way it's architectured. Green will always have a preferred path going over controller A, will have the fastest access to the data. Red will actually go over B, and blue might go again over A, and then what's other color we have? Other colors. So what you get is, since this is sliced in a lot of smaller elements, there is automatic load balancing by design over these two systems, and that means that any read activity will be delivered by each system, and any write activity can also be processed by each system. And when it happens, either read or write, it's always in the optimal way. There is no need for tuning or for load balancing of this architecture. And this is not only true for this volume, but we will allow that to happen on each volume. So by design, if the more hosts you add to this, each host has his own virtual machine, and each virtual machine has a different process in touching these colored bars. By design and by architecture, all of these volumes will actually start using all paths available. If you have a failure on one of these paths, nothing happens, because there's always an alternative path for you to go there. So in terms of availability, this is also much better. And also, if you ever want to upgrade your storage device, there is no need to do failover. I mean, everything is active. It's massive parallel. It's very easy to upgrade one controller while the other is just processing the data, and then I'll upgrade the other one while this one is processing the data. So we're really going into this active, always on, always stable, and actually providing data at the most optimal way for the lifetime of the device. And it gets even better. What we can do is actually replicate this volume to another array in the other data center, and we can create what we call a hyper-metro domain between these two arrays. And if we do that, we create actually a virtual domain or a virtual volume that is living between these two systems. And this virtual volume will actually be seen by each node as a central repository to which they can write. So that means that there's no more this idea of a standby buddy. All systems start participating in all I/O processes, meaning, this volume could read here, it could read here, it can write here, it would write green here, it could write red here. So it's becoming a massive parallel infrastructure, very reliable, very performant. Also, as a result, if you ever have a failure on this device, the I/O in this whole architecture just stops functioning for 1 or 2 seconds, no more, and then it continues here. And the only thing the host will notice is that that they just, instead of seeing 4 paths, they went down to 2, but there's still 2 paths over which they can continue. If the host comes back up, the host will announce that there's 2 more paths available, and then he will start spreading. There is an automatic sync and resync, so that's all built in. But there is an automatic continuation of the I/O. So that's another big advantage of this active architecture. Last element and last very nice idea is, if you ever move this architecture over very large distances, meaning more than 100 kilometers, you could actually have an issue, meaning the I/O delay from this side to that side and coming back, so that would be 200 kilometers, would result in a delay of 1 millisecond actually on this side, while the I/O delay over here is let's say 100 microseconds. So what you don't want is that these volumes, if you're having an architecture which is stretched over huge distances, you don't want these systems to actually boundary continuously this system. So if we have software that will actually help these servers to tell that any I/O you do, you always do it locally, and then the same is true for server 3 and 4. Any I/O you do here, you can actually do it locally. Now, what is bringing this to the table is that if you have a virtual machine that is living on server locally, but in case you ever have a vMotion, so I'm not talking about a storage vMotion, just a vMotion, this VM actually moves to over here to this server, the host that is sitting here will tell that VM, if you write to the system, you always do it locally. So you can move VMs around in this cluster, and wherever the virtual machine is, it will always get the best possible I/O on the architecture. And only in case of disaster, the remote array will be used to continue the services. And the same idea could actually be reused if you ever want to migrate data from one platform to the other. We can, it's the same architecture. You have this device, you put in a new device, you create a hypermetro domain, you move the data over from A to B. The host will not know that the data has migrated to the other side, and then you can tear down this system. So we're also promoting this idea of a continuous availability concept, and the idea is that you never ever need to migrate data anymore in your life. Okay, so this is a lot of technical stuff, huh? And now I'm trying to translate all these technical elements into some commercial advantages. So first of all, commercial advantages of an active architecture. So first, I hope you understood this, that resources, any investment you do in today's architecture, you waste a lot of resources because they're used as a standby buddy. And that's not happening. Everything is used constantly by all systems, automatically load balancing. These systems are also extremely compact in design. Most architectures that we build are just 2U, very compact. So any customer that is paying for co-location or is paying for rack space, we can reduce your architecture from several U's, or I don't know, to 2U solution. Because everything is active and it's always balanced at all times, you get a lot more performance for your solution, and that indirectly also has a huge beneficial effect on your compute servers. You might be able to extend the lifetime of your compute servers just by replacing your storage, because we're effectively eliminating all latency that you have ever seen in your architecture. Since everything is by design load balanced and distributed, you could actually avoid paying consultancy fees for audits. You don't need to pay, you don't need to have, and also any uptime or any upgrade that you will need to perform on these systems, you don't need to precision any downtime. This can be just during the business hours. The systems will not see that they're actually being done an upgrade. And that's something we're promoting. And if business continuity is important to you, actually the solution is very easy to build. And any disruption in storage services disruption in storage services will be less than a few seconds. So what we're saying is you can double your services level towards your arrays, but we're actually halving the infrastructure cost because you don't have that standby buddy idea anymore. So that was the commercial advantages of active-active, and this is an advantage primarily towards, how would I say, investment, equipment, availability, performance. But since we're all flash, I think what you see, if you would see a proposal from us, you would see that probably 90% of the cost of a proposal is defined by the number of solid state disks you have in the array. And so reducing that amount of solid state disks will actually greatly impact the total cost of your architecture. And for that, Huawei has invested a lot of time and energy to actually help reduce the amount of data that is physically stored on the array. And this is what we call data reduction. And there are three big data reduction technologies built into this array. There's data, and we will discuss each of them. And why am I talking about this? Because I think we have some reduction technologies that are really unique in the market and you will not find with other vendors today, or not today, maybe in 1 year or 2 years from now, but we're really leading in this space. And the first idea around deduplication, I think deduplication as an idea is not unique. It's been there for, I think I've seen it, the first time I saw it was almost 12 years ago. But at that time, what deduplication was a lot about is about finding blocks that are quite similar. And actually, if there is a 100% match, then we can say we can remove one block and just keep, and have a gain of 100% of capacity. But what you will find is as soon as you start using that technology, is that very seldom all blocks are identical. And there's always some bit of a shift or a change between those blocks. So it's a lot more beneficial to actually look at what we call similarity-based deduplication. And the idea is the following. Supposedly we have 4 blocks that have names in there. So what we will do is we will run an algorithm on this, and that algorithm will actually identify that most of the data in a block set is almost the same. Not everything, but there is some, a lot of elements are identical, but a lot are not. And this will allow us to identify these blocks, as you see in this picture. These are 5 different sentences, but at least in terms of calculation, 4 of them result into a huge similarity, and there's only one not resulting in this similarity. So what we do next is actually take those 4, and what we will identify in this architecture is the blocks, or we will pick one block as a reference block, and then we will select from those other blocks the data that is different from the reference block, and that will actually be written to the system. So by doing so, and this is unique in the market, we can achieve a much higher deduplication ratio than any other device we've seen, and that's coming. We've done tests in our labs, and we actually have proof for that. Second thing, after deduplication, what we also do is compression. And compression is a good way to reduce data but there's a problem also with compression. What you will find is that some data is very easy to compress, and other data is very hard to compress. So the system will actually detect what is easy to do, and will do it immediately. And items or blocks that are very hard to compress will actually go in a post-process compression algorithm, and will use a lot of smarter ways to actually find similarity-based compression, and or similarity-based deduplication and similarity-based compression to actually reduce that piece. So so that's very key in our design, in our architecture. And then last element that we're actually introducing in terms of data reduction is data compacting. The idea of data compacting is that after compression, so what you see here is some data sets. What you will do is actually use compression to reduce the data sets. But if you would write that to disk, you have a huge loss in gaps between these systems. And what we're going to do is actually stitch these blocks. So you see these losses here if you have an alignment by 1 kilobyte. So there's loss here if you don't do compacting. So in compacting, we're actually going to, this alignment is being removed, and we're going to a 1 kilobyte, or we're inserting a byte, one byte, so 8 bits. 8 bits between these blocks to ensure that they're all actually stitched together, and we will write that as a single element to the array. So why is this important? Well, if you start talking to customers, what they want is they want to pay as little as money possible for the best technology. And by using data reduction, you can actually achieve that, because, you know, imagine you have a system that has a data reduction of 1 to 10, then maybe you only need one disk to store 100 terabytes. So that's the idea. Now, what I'm saying is not possible today, 1 to 10, but it's this general idea. So what we're doing when we make a commercial proposal to our customers is that we will scan the data of the customer, and then based on that scan, we have an estimate how efficient we can reduce his data set in the environment. And then based on that scan, we will come back with a reduction ratio. In this case, we are having a reduction ratio of almost 2.4, 2.3. And then commercially, we will tie that reduction ratio to a contract where we will guarantee the customer an effective capacity, so a usable capacity. And this contract, which is also unique in the market, we will make available not just for initial purchase, but for the lifetime of the contract. And so any time the customer will go over this reduction ratio, as a company, we will step in and actually ensure that he gets back to this commercially agreed data reduction ratio. So if you look in the market, this sort of programs are not unique. What is unique with us is that we will do it for the lifetime of the contract, so maybe over a period of 5 years. And also we will do it involving any additional purchases. So if we need to add equipment, we will pay for the disks, we will pay for the shelves, we will pay for the services. So any cost that is related to ensuring that they get this capacity guarantee will be on the cost of the vendor, the supplier, and not the end customer. So that's quite unique also in the market. Okay, I think I've come to the end. So I've come to the end about Dorado V6. There's a lot more to be told, and if you have more interested, feel free to reach out to us, and we could set up a session. We could deep dive into this, or take some time to read the white paper. And get to an understanding of what we're actually achieving here. Now I'm finalizing with a view of the customers, and this is a limited list. I think when you're providing or building solutions in the Belgian market as an integrator, what you will see is that you have big customers and you have small customers. And I think commercially the best solution is a solution that you can sell to a small customer with a limited budget, and also to big customers with a big budget. So for you as an integrator, it's quite easy. You need to know one solution, one concept, one idea, and you can drive that into your customer base. And I think if you look at this list, you actually really see an example of why this is working in the Belgian market. There are some customers on there who are very, very small with a very limited budget, and even they can enjoy the benefits of huge data reduction scenarios and an active-active architecture. But on the same time, what you see is some very high-profile customers like Proximus or P&V Insurance or UCL Saint-Luc, who are really huge enterprises that are enjoying, that have very demanding and very high-performant environments, and are also being able, and to which we can also provide these very high performance, high demanding architectures. Yes, I think that's about it. I don't know if there's any questions about this talk. Let me see. No. I need to see.
I see no question in the chat, so if someone has a question, he can unmute himself and ask a question to Hugo.
Okay, that's easy.
Yeah. Also, if you have questions later on, there are some Huawei representative at the moment on the Huawei virtual booth in the Expo, so don't hesitate to get there, have a chat with them if you have additional question, or if you just want to download some documentation, just do it. It's available all day.
Okay.
Okay,
Good.
thank you, Hugo. Thank you, Eric.
Thank you. Thank you very much. Have a good day. Bye-bye.